Welcome back to the online sessions of signals and systems. Now today in this session we normally going to do some problem on the periodicity. Okay, so what is basically a periodic signal? Any signal which is normally going to continue after a fixed interval of time period, and the form of the signal and shape of the signal is not really going to change, then that type of signal is known as a periodic signal. So every periodic signal is normally going to satisfy a condition x of t. If it is equal to x of t plus n times t, then it is simply known as a periodic signal, where n is going to take the integers, from 1, 2, 3 so on up to infinity. So where n is going to take 1, 2, 3 so on up to infinity. So n is going to take n number of values. Now for all these values, this particular time shifted signal should be equal to x of t. X of t is the actual signal without any time shifting. Without any time shifting, you should get the same signal value. If these two are equal, then we say the signal is going to be a periodic signal, otherwise it is not a periodic signal. So if it satisfies this equation, we say that it is going to satisfy the condition of periodicity. So that means this is going to be the condition of periodicity if at all the signal frequency is going to be single signal frequency. That means if the signal is going to be only one signal is involved in this, then for that signal we can apply this particular condition to solve for the periodicity. So before we now here, in order to solve for this, we should find out the value of this capital T. That means, so basically a signal means what? How a signal is normally going to look like for us. So you can just imagine a signal like this. So this is varying with respect to time period. So some amplitude called voltage. Now if you observe carefully, this signal is taking the time period, say capital T. Now this capital T is going to get repeated, right? So next period also it is going to have the same time period. So for infinite number of durations, the time period is normally going to be same. So if this is the case, that means same signal is simply getting repeated over the time axis, over the time period. So therefore, if a signal is getting repeated continuously on a time axis, we say that the signal is going to be a periodic signal. So we have to prove that particular thing now. To prove that, first of all, now let us suppose the signal given is cos 2 pi t of square. Cos 2 pi t square is the signal, let us say, given to us. So first of all, what you have to do now in this is you have to find out the value of capital T. So you have to find out the value of capital T. First of all, find out this. Once you find out the value of capital T, then substitute this capital T in the equation to get into the final solution. Now let us start working with this now. Say x of t is given as equal to cos of 2 pi t, okay, square. This is what the formula given to us, So I can write this x of t is equal to, it is in the form of, what is the form of this equation we have? Cos square x is equal to 1 plus cos 2x by 2. So this is the formula we are going to have for the cos square x. So we'll substitute that formula over here and we'll rearrange the equation. So what is that we can write now? 1 plus cos 2 into x. That means here, what is the x in this now? This is what x that you're going to have now. So that means I can write here 2 pi t by 2. Okay. So this equation I can write as now x of t is equal to 1 by 2 plus 1 by 2 into cos of, this is going to be 4 pi t. Now the first component is DC component. This is known as a DC component. So for a DC component, we are not going to have any frequency. What is the frequency of a DC signal? It is going to be 0. How can I say that? Say, what is the meaning of DC signal? Over a time period t, a signal is not changing. Say there is a voltage signal like this. If the signal value is not changing over the infinite duration of time period, then we say the frequency of the signal is equal to 0. How? Because we know the formula for frequency. What is the formula for frequency? F is equal to 1 by t. Now what is the value of t here? T going to infinity. So I can have 1 by infinity, which is equal to 0. So the frequency of a DC signal is equal to 0. Now here also, since there is no time period here, we say that it is a DC signal. So for DC signal, you are not going to get any time period or a frequency component. Now here we have a time period here, right? Now this particular equation in the form of cos omega t can be approximated to cos 4 pi t now, right? So here using this equation I can equate omega t is equal to 4 pi t, right? Now what is omega? Omega is nothing but is equal to 2 pi f into t is equal to 4 pi t. Alright, so this t will simply going to get cancelled. F is equal to 4 pi by 2 pi. F is equal to 4 pi by 2 pi. So pi will get cancelled, 2 times it will go. So it is going to be 2 hertz. We get frequency is equal to 2 hertz. So since frequency is equal to 2 hertz, what is the time period? Time period is inverse of the frequency. So therefore 1 by 2, which is equal to 0.5 seconds, is the fundamental time period of the signal. So this is nothing but the fundamental time period of the given signal x of t. Now let us try to solve this equation by substituting the fundamental quantity in this. So by substituting fundamental quantity means what I should do now? What is the equation given to us? Cos square x. Okay, that is how normally the equation that is given to us. So this equation I should write as cos square x plus t form. So in this form I have to write the equation actually. Okay, right. Now what is t here? We got t value as, how much is the t value? 1 by 2, that is equal to 0.5 seconds. We got the value of t. Now since we got the value of t as 0.5 seconds, now let us substitute this in the previous equation, in the earlier equation. Okay, in the earlier equation, what is that I have now? It is cos square. I can just expand this now equation now. So I can write now cos 2 pi, here cos of 2 pi of, instead of t it is going to be t plus 0.5. This is what I write. So this is the equation that we are going to have whole square. So this is the equation that we are going to have. Now we have to solve that equation in order to get into the periodicity. Now how can we write that equation as? We can write that equation as cos square theta, something like that. So I can have this as cos square 2 pi of t plus 0.5. Same as the previous one, cos square theta. So just now we got this now cos square theta. Similarly, I will be having this one also. So here, what is the formula now I have? Let us substitute the formula for this. So this is nothing but x of t plus t. X of t plus t I can write as equal to this. So therefore x of t plus t can be written as equal to cos square 2 pi t plus 0.5. This is what equation I can write. Okay. So cos square theta form I am going to have similar to the previous one. Cos square theta is equal to 1 plus cos 2 theta by 2. So similar form I will write now. So therefore this is equal to what I can have? 1 plus cos, what is the equation I have? 1 plus cos 2 theta. So 1 plus cos 2 into 2 pi of t plus 0.5. Alright. So by 2. So this is the equation I get. Now once I get this equation, what I will be having now? It's going to be like 1 plus cos, how much is this? 4 pi plus, what about the other guy? This is 2 pi into 2, 4 pi. This is going to be 2 pi into 0.5. What is 0.5? It's going to be 1 by 2. So therefore, these 2 and this 2 will get cancelled. I am normally going to get 2 pi here. Okay, 4 pi, let's write this completely. 4 pi t plus this 2 and this 2 will get cancelled. This is 0.5 is nothing but 1 by 2. This 1 by 2, 1 by 2 will get cancelled. So I will be getting here as 2 pi, alright, by 2. So that is the equation I am going to have. So this is the form. What is the form we have got? Cos A plus B. So we should know some of the trigonometric formulas here. We should know derivations. We should know a little bit of integrations to get into to solve the mathematical equations. So now this is in the form of cos of A plus B. What is the formula for cos of A plus B? It is going to be cos A cos B, cos A cos B minus sin A sin B. That is the formula for that equation. Now while solving this equation, what I am going to have now? This 2 will get cancelled. Finally I will be getting this equation as it's going to be cos of 4 by t plus 2 pi whole by 2. It is in the form of cos of A plus B, cos A cos B minus sin A sin B. Now we expand this. What is A? 4 pi t. What is B? 2 pi. So similarly for sine, 4 pi t into sine of 2 pi I will get. Then now here, what is sine 2 pi? Sine 2 pi is 0. Sine 2 pi is 0. What is cos 2 pi? Cos 2 pi is equal to 1. So therefore I left over with this particular factor. So I can write this as 1 by 2 of cos 4 pi. So which is nothing but equal to 1 plus cos 2 into 2 pi, t is there here, 2 into 2 pi t whole by 2. So which is nothing but equal to what now? Cos square 2 pi t. That is the equation I got, which is nothing but equal to x of t. Nothing but equal to x of t. Now since x of t is equal to x of t plus t, I can say that this is x of t plus t. X of t plus t is equal to x of t now. Because these two are same, I can say that this signal is going to be a periodic signal with a fundamental time period of 0.5 seconds. So this is how we normally perform the activity called periodicity. So whenever a problem of this kind is given to us with a single frequency component, you have to adapt this particular method to find out the periodicity of the signal. So whenever this condition is satisfied, we say that the signal is a periodic. Having discussed about the periodic signals, now we normally go with another type of signals that is known as a deterministic signals and a stochastic signals, right? Now what is the meaning of deterministic signal? That means if the value of a signal is going to get predicted, if the future values of a signal is going to get predicted, that particular type of signal simply comes under the deterministic signal. That means if a time period at any given time is given to us, then if you could able to find out the value of the signal, then we say that that type of signals are going to be deterministic signals. And if you could not really find out the value of a signal when we give a time period, is known as a stochastic signals or known as random signals, or can also be called as a non-deterministic signals. So therefore we have two important types, that is called deterministic and stochastic type of the signals. Say for example, if you have a sine wave like this. Now we all know a sine wave, imagine it is varying with respect to some time period. Say there is a sine wave like this. Now this sine wave is varying, okay. So from 0 to, for example, infinity. The sine wave is varying from 0 to infinity. Now here these values are going to be, say, pi by 4. This is going to be this is going to be pi by 4. This is going to be pi. Okay, like this we are going to have the values. Now say this particular signal is going to be called as A sin omega t. A sin omega t. Generally theta plus theta will be there. So if theta is equal to 0, what I can write this function as, say, x of t. I may call this function as x of t. There is a variable called x which depends on the time period t. Therefore, we will write this function as x of t. So once you write this function as x of t, how I can write the equation for the sine wave? A sin of omega t plus theta we can write. A sine of omega t plus theta we can write. Okay, we can write. Now if theta is equal to 0, what I can write this equation as now? Simply x of t is equal to A sine omega t. So this is the equation I can get if theta is normally going to be taken as equal to 0. Because we are starting the theta value equal to 0, phase angle is going to be equal to 0, and the signal is simply going to get repeated continuously at each and every value of time. That means this signal, if it is really getting repeated continuously, it comes under definitely a periodic signal. So now this can also be called as a deterministic signal. That means if you know the time period, or if you know the values of this signal at a particular time period, now you can able to know the values of this signal for the future also. That means after time t is equal to t, capital T, after time, so we can just say after t is equal to capital T, we could able to find out, or if you could able to find out the values of the signal based on the present values, we simply call that type of signal going to be called as a deterministic signals. So that means the stable signals can be normally called as a deterministic signals. That means whose values are normally not going to get changed. So those kind of signals are simply known as a deterministic signals. So here we can find out the values of the signal now. Say here just at pi by 4, sine pi by 4, you can find out the value. At sine pi you can find out the value. So sine pi is nothing but equal to 0. So if omega t is given as equal to pi, so x of t becomes simply equal to 0. Then if omega t is equal to, if omega t value is equal to some other value, say pi by 4, if it is given as equal to pi by 4, then you normally going to get the maximum value. That means x of t becomes equal to a. Now these values can be computed by knowing the by applying the value of the time period. That means at any given time, if you know the values of signal for a particular time, you should be in a position to find out the same values at a later time also. If you could able to determine them, that is known as the deterministic type of the signals. Now another type of signals that we have, which are going to be called as a stochastic signals. The first one is going to be deterministic signal. So these type of signals are deterministic. Next one is stochastic type of the signals. What is stochastic? Normally these random signals can be called as a random signals. I can call them as random signals also. Stochastic signals or random signals means the value of this signal cannot be found out. Say for example, now this signal, say the voice signal can be computed like this. So this signal is going to be in the form of voice signal. So voice signal is going to be like a random signal. So it can be called as a stochastic signal. It is known as a voice signal, say for example. So any signal whose value cannot be found out at a particular time period is simply known as a stochastic type of the signals, are known as a random type of the signals. Okay, so these are the two important concepts which we have. The next one is going to be absolute integrability. What is absolute integrability? If the integration of the signal over a limited time, over a given time period, say t1 and t2, if it tends to infinity, over a given time period tends to infinity, means what? Infinity stands for finite. If it is finite, if the integration of a signal over the given limits is finite, then that particular type of signal is going to be absolute integrable signal. That means we can able to find out the value compulsorily for this kind of a signals. That means any signals whose values can be found out by a process of integration, that means definitely that type of signals are simply known as a absolute integrable type of the signals. So if this is so, we say that it is absolute absolute integrable signals. Absolute integrity. It is simply following the condition called absolute integrability. Okay. So these are the concepts which we have as per the signal properties are concerned. Now next we go with other part of the signals, that is going to be the some signals of some importance, signals of some special signals of some importance. So we can have in the syllabus special signals of importance. Special signals of importance. What are those signals which are important for us? That is given in the syllabus. He has given in the syllabus as unit step signal represented by u of t. Unit step signal in a time varying signal represented by u of t is known as a unit step signal. So what is this signal now? Already we discussed this signal when I am discussing the introduction class. So where I have just written like this. So if this is 0, the signal is going to be there here, unit step. Up to 0, the values of this signal is normally equal to 0. That means here you normally going to have the signal here. Okay. So before that, before this 0, the values are normally equal to 0. So after this, you normally going to have the signal. So this signal is known as simply u of t. U of t is known as unit step signal. Now how do we represent this mathematically? U of t is equal to 1 for all t not equal to 0. Now whenever t is equal to 0, that means this value is is normally equal to 0, is normally equal to 1 for all t greater than 0. For all t greater than 0. For all t greater than 0, this value would be equal to 0. And this value, if it is equal to 1, otherwise, we simply call this type of signal known as a unit step type of the signal. Right? Now another signal we have going to be the unit ramp signal. Unit impulse signal. Ramp is not given in the syllabus. So unit impulse signal. Next one is going to be unit impulse signal. We represent this by delta of t. We represent this by delta of t. What is this delta of t? I can write this as now. This is a impulse. Impulse means what? Say if you write a time axis t, there is going to be a signal of delta of t in a given time period called t. 0. T is equal to 0. That means if you have a signal here like this, this is known as a unit impulse signal. So I can write this signal, or else I can draw a signal like this also. I shift this signal over the time period. When I shift the signal over time period, I can draw like this. So this is also going to be a signal now. So now the unit impulse signal, how I can represent now? The time shifted signal. That means if you are shifting this time period towards the positive side of the time period t, we can write this as del of t minus if this time period is equal to t naught. So this signal is delayed version with respect to this signal, because after time t this signal is coming. So therefore we call this as a delayed version of this particular type of the signal. If the amplitude of the signal is equal to k, if this is equal to k, I can write the entire signal is equal to k times delta of t minus t naught, where this k is known as the amplitude of the signal and delta is the actual function representation, and this delta is represented after the time period t. Therefore this is nothing but a time delayed version of the signal. It is known as a time delayed version. Time delayed signal. So this type of signal is known as a ramp signal. Now how do we represent this unit impulse signal? How do we represent this unit impulse signal? This impulse signal we can represent as equal to delta of t is equal to, how we write this? We are normally going to have a function only at an instance where we are really going to find out the value. That means only at an instance we normally going to have the signal here. So that means this value is going to be now delta of t would be equal to 1. Delta of t would be equal to 1. Delta of t would be equal to 1 only at that means for all t not equal to 0. For all t not equal to 0. So I'll write this as for all t not equal to 0. What is the meaning of this? Except t is equal to 0 for all the time periods, except t is equal to 0 for all the time periods, except t is equal to 0 for all the time periods, the value is equal to 0. So I can write this as 0 now. So for all t not equal to 0, that means t less than, when t goes negative side, when t goes positive side, the value is going to be 0 under consideration. Then that type of signal can be called as a unit impulse signal. So we can as well write this as equal to 1 otherwise. This is one way of representing the signal. Another way of representing this is going to be delta of t is equal to, I can write delta of t is equal to 1 at t is equal to 0, at t is equal to 0. Okay, so then we can call this as a unit impulse type of the signals, and it is going to be 0 otherwise. In all the rest of the other parts, it is simply equal to 0. So which is known as a unit impulse signal. So with this we have two types of special signals, special function signals called unit step signal and a unit impulse signal. So now this unit impulse signal is normally used for sampling. Whenever we wanted to convert analog signal into a digital signal, then we normally going to use this type of a unit step and unit impulse type of the signals. Okay. Then after these signals, we have another type called sine wave signals. Already we have discussed this is a sine wave signal. Okay. So this is a sinusoidal signal. Sinusoidal means what? A cos wave or a sine wave can be called as a sinusoidal signals. Okay. A cos wave or sine wave can be called as a sinusoidal signals. Why cos is called as sinusoidal? Because it is varying sinusoidally. It is varying with respect to time in a alternating manner, in a continuous alternating manner, and hence cos wave is also known as a sinusoidal signal. Okay, so that means we normally going to represent a sinusoidal signal something like, if it is starting with 0, we start with 0. Unlike this, how I can really start here now? Let us see this now. Say I am drawing a cos wave signal now. Cos means what? It is going to be reverse of sine. So that means, say for example, I am drawing a signal something like this. What is the phase now? The phase of the signal is starting from here. That means it is involving some phase. This is the phase angle that we normally going to consider, theta. So therefore, we can write this as cos of omega t plus theta, which is nothing but a cos wave signal, which contains the time period t. So if I am going to consider this, which is containing the time period t and frequency and the angular displacement theta. So therefore, we can represent this sine signal or cos signal. So these two signals comes under the sinusoidal type of the signals. Then last type that you are going to have is called as exponential signals. Exponential signals. Exponential signals. Now how can we represent exponential signal? Say x of t is equal to a into e raised to power delta e raised to some lambda t. Okay, so you can put any constant here, some lambda t or anything else. So e power some lambda t or sigma of t, whatever it is, you can put. So now here in the case of exponential signals, we are going to have real exponential signals, we are going to have complex exponential signals. So this is once again reconverted into two. That is going to be the real and a complex type. Complex type exponential signals. Now coming to the real exponential signals, we are going to have a real exponential signals. Real exponential signals. What is the meaning of real exponential signal? Means what? It's going to be like the value of this x of t is going to be the real value. The x of t value, if it is going to be equal to real value of a into e raised to lambda t, then we simply call it as a real exponential type of the signals. Real exponential type of the signals we can normally going to specify. That means here we normally going to have three modes. We normally going to have three modes of signals. Three modes of signals. What are the three modes of signals we are going to have? Lambda, based on the value of lambda, if A is taken as constant, real value, lambda is going to take three values. One is going to be lambda greater than 0, lambda is equal to 0, and lambda less than 0. Three cases we normally going to have it here. So we'll discuss about these three cases. If the lambda is greater than 0, lambda is greater than 0 means what? Going towards infinity. Means what? E power plus infinity. As e power plus infinity, as e power is increasing, the value is also normally going to increase for us. So therefore, for this type, what kind of waveform we normally going to get? We normally going to get exponentially increasing signal. So this is nothing but simply A into e power infinity signal. With respect to time period t, it is going to be x of t. So the increasingly exponential signal we are going to get if you put a condition lambda greater than 0. Lambda greater than 0. Okay. Next one is lambda is equal to 0. When you look into this lambda is equal to 0, what type of signal you normally going to experience here? The signal you are going to get is lambda is equal to 0. Means what? This is 0 time period. Something like e power 0. What is e power 0? It is going to be 1. So therefore, as it is going to be 1, you are normally going to get a signal like this. A DC signal kind of a thing you are going to get. You are normally going to get a DC signal here when this particular lambda becomes equal to 0. Then similarly, lambda less than 0. Lambda less than 0 means what? T is going to take the negative values. So as T is going to take the negative values, what is the signal you normally going to get now here? The signal you are going to get it is here, something like, now this is for lambda is equal to 0. So which is nothing but A into e power 0, which is equal to, which is nothing but x of t for us. Okay. The next last one is lambda less than 0. When lambda less than 0, what will happen now? You normally going to get exponentially decaying signal. The signal is going to be something like this. So this is going to be 0. We normally going to get A. So at something like minus infinity, e power minus infinity, we normally going to get it is exponentially decaying signal. So I can have this as x of t is equal to A into e raised to minus lambda t. It is a decaying exponential signal we normally going to get. So this is how the various types of the exponential signals we are going to have based on the real values of this particular signal. And apart from this, we normally going to have the exponential values of the random signal. That means what? Exponential means what? You are going to get a real part as well as the imaginary part. So whenever you are going to have real part and imaginary part, then we normally going to have the sinusoidal variations. Normally it is used in the applications of amplitude modulation and digital modulation. So all those things. So those things we normally discuss in the next class. So the next class we will discuss about the complex exponential signals. So with this we will complete the various types of the signals by doing so. Thank you very much for today's session.